Okay, good evening, everybody. So today we're going to start 10.2, which is chapter second section, chapter 10. We're skipping the first verse for a couple of days. We'll come back and pick it up in a little bit. But we're going to start graphing quadratics. And so this is a pretty big topic. And I mentioned at the beginning of the year that we'll be doing tons of graphing. Well, this is yet another chapter where we will be doing tons of graphing. Our whole deal is for this chapter is learn how to graph quadratics. And quadratics make a special type of graph, which are called parabolas. Okay, and so anytime you have a quadratic, which means you have x squared and nothing bigger, then your graph should look like a parabola. If it doesn't look like a parabola, you've done something wrong. So these will not be linear. They won't be straight. They won't be straight lines. They're going to be a parabola. And a parabola is a curve. You're going to see what parabolas look like here in just a minute. So that's the first thing we want to look at. When you see this equation right here, and you go, oh yeah, I got x squared and nothing bigger in this whole equation, that means my graph had better look like a parabola. Hopefully another thing you're looking at this one after last chapter, you go, hey, look at that binomial. It's subtraction, and that's a perfect square, and that's a perfect square. So if I had asked you to factor this, we could have done a shortcut. You do not want to stop looking for those shortcuts. Every time you see a quadratic, you want to start thinking, what do I know? Can I do a shortcut? Can I not do a shortcut? Can I do a 1-story, 2-bedroom, 1-story, 3-bedroom? Can I, factor completely? Well, all those things still come into play the whole rest of this chapter. Okay, so let's take a look at it. So right now, the only way we know how to graph this is doing a parabola is the same way we learned how to graph at the very beginning of the year when we were doing linear equations, and that was to set up a t-chart. So we get an x and y like this, and my rule still stands. Whenever you do a t-chart, you have to do 5 numbers, 2 negatives, 2 positives, and always 0. So I'm going to do -4, -2, 0, 2, and 5. Okay, or excuse me, not 2 and 5. Back that up, 2 and 4. Okay, so 2 and 4. And again, it's good to be symmetrical. If you do -2, then do +2. If you do -4, do +4. It makes it kind of nice that way. But really, as long as you do 2 negatives, 2 positives, and always 0. All right, so now, very important for this that we use our parentheses. If we don't use our parentheses when we plug in, we're going to make some mistakes. So I'm going to go ahead and start putting these in. Excuse me. So I have -4 squared minus 9. So -4 squared is 16, and 16 minus 9 is 7. But in my next one, -2 squared. -2 squared is 4. 4 minus 9 is -5. But in my next one, 0 squared. 0 squared minus 9 is -9. And then put in 2 squared again, that's 4. Minus 9 is -5. And plug in a 4. And that's 16 squared minus 9 equals 7. So I'm not going to do this work every time. I'm gonna go a little quicker. We have a lot of slides to get through. I'm gonna go through a little quicker, so this won't be done every time for you. But you should be using the parentheses every single time, writing it out, getting the right answer. Okay, so flip to the next side. And we see I already have the t-chart there. Now I'm going to graph it. Okay, so I'm going to graph this one. So I go -4 and then +7. That would be right here. And again, you're using graph paper, so your graph should be a lot better than mine. -2, 5 would be right there. And 0, -9 would be right there. Then we have 2, -5, which is right there. And then I have 4, +7, which would be up here. Okay, couple things. So here's my line. Here's my graph. So now I'm going to connect my points. And my graph goes like this, and then comes back down. And that's the shape of a parabola. Okay? There's some things that I want you to talk about. Yeah, I want you to test every single one. This is a good 5th color right now. I want you to test every single time if your graph is going to cross the y or the x-axis. If it does cross the x-axis, you should plug in the value to make sure that it crosses there. So that means make sure you get a point up here so that when you connect those two, they cross. It may not cross right at a lattice point, but I always want to see where the parabola is crossing the x-axis. So basically what I'm saying is, let's say you plotted these points like this, you came down here and you stopped right there. Nope. plot another point up here so that you connect it and you see where it crosses the x-axis. That's super important. The next thing is that I want you to note is this right here is called my vertex. Okay, so the bottom point, or if you happen to have a top point, it's called your vertex. So right there is the vertex, and it is the highest or the lowest point on your graph. It's also called this would be called a minimum. Minimum, because it's the lowest point on your graph. If the graph were going the other way, of course, it would be a maximum. So these are also minimums or maximums. This, of course, is a minimum for this one. I'm going to write that a little neater. Okay, that's a minimum, and it could be a maximum for this one. This is a minimum because it's the lowest point of my graph. Okay, so a couple things there. That's just what I wanted you to note is we always want to cross the x-axis with our points, and you can find the minimum and the maximum, which is also called the vertex. Take a look at the next one. And that, by the way, that parabola is graphed. So that is the graph. All right, here's another one. So we have another quadratic. And so I see this quadratic here, and I think, okay, what do I know about it? Well, I can't factor this one by doing any shortcuts because that's not a perfect square. All right, so then I would, if I were going to factor this, I'd do a generic rectangle and diamond problem. We're not going to do that today. We're not going to factor. We instead are just going to plug it in. So I have -2. And again, you should be doing the parentheses every time for this. I'm going to go quicker. So, you're going to have this plus x. And then, oops, I shouldn't have x in there. And then, all of these. You should be writing this out each time. I'm not going to, but I do want to see that in your work. I'm just going to put it in there. So I believe if I did these correctly, I'd get -4, -6, -6, -4, and 0. Okay, so there we go. So if you work those out, I think you should get the same ones that I got. If I made a mistake, we'll find out in a minute because my graph won't look right. Okay, so go to the next slide. Oops, my graph is gone. -2, -4, which would be right there. I'm going to plot -1, -6, which is right there. I'm going to plot 0, -6, which is right there. I'm going to plot 1, -4, 1, whoops, I did that wrong. Let me go back, sorry. Erase that one. I didn't plot 0, -6. So 0, -6 is right there. And then I plotted 1, -4, which is right there. And I plotted 2, 0, which is right there. Okay. So, a couple things I want to point out here. If we remember from graphing at the very beginning of T-charts, these were the 2 negatives and 2 positives we like to use because they were easy. They were small, easy, our graphs were easy. 2 negatives, 2 positives, you got everything I needed. Great. Problem with this is these values may not be wide enough to make sure that these values are going to cross my x-axis. Let me show you what I mean. If I draw my line in here and I go like this, before I move, so at this point right here, most students are going to do this incorrectly, cut straight across. We don't cut straight across on a parabola, even though that's where the 2 points are. We need to have a single point that is my vertex, a single point that's my minimum. So what I never do is I never come down, cut straight across, and then go back up. That's not what a parabola looks like. So we did not, because of the numbers we chose, we did not find what number is the actual lowest. But all I want you to do right now, we're going to work on that in a couple days. I just want you to show me that you know it should go down below these. So you just kind of round it off at the bottom. I don't really care where it is right now. It's just make sure that you do not cut straight across. That would be an incorrect graph. So you get to that point and that point. Whoops. You get to these 2 points right here. This point and this point. Do not cut straight across. Make sure you do a 5th color on that. Instead, just round it off at the bottom. We'll figure out where that vertex is exactly in a couple days. So then I come to this one, and I come right here, and I stop. Well, the problem is that this did not finish over the x-axis. So I have to do at least one more point, because I want to make sure that I always get out to the x-axis. So these 5 entries weren't enough to get my graph all the way back up to the x-axis. So I have to add a point to it. So I'm going to go ahead and add a point right here. I'm going to add, if I can get my colors going, negative 3. And the reason I added negative 3 is because I left off at this being negative 2 right here, so negative 3 would get me a little bit higher. So I do a negative 3, and then negative 3 equals 0. So then I come back and I plug in negative 3, and that's 0, which is right there, and that's exactly what I wanted. I wanted it to at least get to there, and then I can just extend it up like that. Another thing looking at parabolas, notice that they always go outward, right? Parabolas don't go up, straight up like that. That's not what a parabola looks like. They always go out a little bit going outward, and they never curve back in, so it's never going to look like this either. I see that a lot from students. They're not going to come down here and like cross at some point. So make sure when you do your parabolas, don't be lazy about that. They're always going outward, not curving back in. Okay, let's take a look at the next example, please. Set up a T-chart here and fill it in. Again, you're going to be using parentheses. I'm going, in the interest of time, I am not going to use parentheses. In fact, I'm not going to show that at all this time. I'm just going to plug them in. So I got negative 7, negative 2, 1, 2, 1. Okay, so make sure that you are using parentheses. If you did not get the values I got, that's because you didn't use parentheses when you plugged them in, and you messed up that negative in the front. That's what makes this one trickier, is the fact this has a negative x squared. So, all right, let's go to take the next slide. Here we go. Here's my next slide, and now I need to plot these. So I'm going to go ahead and plot these. Negative 2, negative 7 is about right there. And then negative 1, negative 2 is right there. And then 0, 1 is right there. And then 1, 2, 1, 2 is right there. And then 2, 1 is right there. Okay, so what we notice this time is that I don't have a flat top or flat bottom. My graph is going kind of like I like it. Rounded off at the top, so that was good. But again, my problem is it didn't come back and cross the x-axis. So I need to plug in one more point. This time, it makes sense for me to plug in the next one out here, which would be 3. So I'm going to plug a 3 in here. So let me plug a 3 in. And if I plug a 3 in and work it out, I'm going to get negative 2. So then I can plot 3, negative 2, which is right there, and then I draw my line, and that's good enough. I don't need to do any more points down here. Okay, so there's my parabola. So in this parabola, we have the vertex, which is right here. It's the highest point this time, so that means this one is going to be not a minimum, but a maximum. Okay, that's a maximum vertex this time. Now, how does this parabola look different than the other ones we've done? Well, this one's upside down. It's flipped over. Here's the equation for this one. This is y equals negative x squared plus 2x plus 1. So what made this parabola flip over? What made this parabola become a negative shaped parabola or an upside down parabola? Well, you're probably beginning to figure it out. It's that negative right there, because everything else was positive. So what flipped it over is the a term. If a is negative, then your parabola is going to be upside down. So we're going back to the quadratics, ax squared plus bx plus c. If a is negative, then your parabola should be upside down. So I don't know what this is going to sound like. I might have totally screwed up my lesson. I tried to go back and look at the previous graph, and it didn't show up very well, and then I don't know what I recorded, so hopefully you got it the first time through. I'll have to review. So anyways, my point is that the negative on this right here flips this upside down. Flips it upside down, And then the when it's positive right here, it's going to be a U. So a positive goes up, and a negative goes down. Okay, last slide right here. I just have some different graphs that I want to take a look at. And the top three are incorrect. They cannot be graphed correctly. We don't know what the equations are because I don't have any points or anything, but I know that these graphs are wrong. The bottom three are fine. Excuse me. So two of them are probably look kind of obvious what's wrong, especially the middle one because we've already talked about it. But so we'll do that one first. Remember, we talked about if you're coming down like this, you're not going to go straight across and then go back up. That just doesn't happen. If you come down like this, you should keep going down and then eventually go back up. So for this one, the correct graph probably goes something like this. All right, something like that. So it's not going to go straight across, okay, ever. It doesn't matter. And if it were going up, you're not going to do this either. That just doesn't happen for our graphs. Our graphs instead are going to look like this. Something like that, okay? So make sure you don't go straight across. It's going to be very tempting because you don't see a point there. Now the next one that looks obviously wrong is probably this one. We're not going to have any graphs that look like a C. Okay, that's something you're going to do in later math classes. Our classes will always look like U's or N's. U's or N's. They're never going to look like a C. And what that means is you messed up the equation somehow. Okay, so these two are kind of obvious. This one you're looking at, wow, it doesn't seem that bad to me. It looks kind of good. I drew it very specifically. Here's what it should look like. Whoops, not like that. Let me try again. Here's what it should look like. I was emphasizing it too much. All right, I'll just have to tell you because I can't redraw it on there. What it should look like is rounded off right here. This part right here should be rounded off. It's not, because what happens a lot of times is you plotted this point, and then the next point you plotted was this point. And instead of finding the points in between, you just drew a straight line. So our graphs are not going to look like this, where they have like a straight flat edge somewhere. That just doesn't happen. That means there's a point in here that you didn't find that would have rounded it off. Our graphs should look very symmetrical, very even, right? They should be evenly spaced. They're not going to be some weird looking graphs. Very evenly spaced. Now, on the bottom, all three of these are correct. So here we see a graph that crosses the x-axis twice. That's perfectly okay. Here we have a graph that crosses the x-axis once. That's okay. Here we have a graph that does not cross the x-axis. That is okay. So we're going to find out these three things have a little bit different equations. We'll get used to using them, but I want you to know that sometimes it can cross twice. Sometimes it can cross exactly once, meaning just touch it, and then sometimes it might not cross at all. Okay, that's it. I'll see you guys tomorrow.